Now let's say in your dungeon you want to find the furthest room from the start point and mark it as something like a boss fight or an exit or whatever. We can find it in two ways. The first one, the easier one, just takes every room and finds the one with the maximum distance between the room and the start. And we are talking about the physical distance, so something based on this transform that position of every game object in this list. Now let's say you generate something like this, so you have another room right here. This one is still the furthest one from the start point, but this room should be our boss room, probably, maybe you don't want it, because this one has the biggest amount of jumps between the room and the start, so we are not calculating the distance between this and that point, but instead we are looking for the maximum amount of jumps between the rooms before reaching the start point. We are going to write a function for that too, but first let's get the easier example. And that's the find furthest room function based on the physical distance. So we need an index, the biggest distance between two rooms, and for every room in our list, we want to get the distance between the room and our room generator. Then if the distance is bigger than the biggest distance, we want to save the index and the distance. And we want to return this room. In case we have this room list empty, we start with an index of -1, and if it's not -1, so we did this at least once, you can return it, otherwise we return null. This probably won't happen unless we make a mess in our application, like a real mess. In the start function, we want to use this function after we generate doors. But this gives us only a room, so it's no use for us for now, unless we use a new function, which is mark as boss room. Let's have a look on it. It's in the room class, and we simply change the color of the center decoration and make it a little bit bigger. Let's see. Okay, and as you can see, there's our boss room. It's the furthest one from the center. Now, as you can see, the furthest room based on this algorithm is this one, because the distance between those two is the biggest distance. But this room has more jumps between the start point than this one. Alright, now things are going to get complicated, so don't worry if you don't understand it well. To be honest, it's the most complicated thing in the whole dungeon generation process. Okay, first new thing is that we use something like checked rooms, which is a list of rooms, and we use it to skip one iteration of this loop if the current room is in this list. Okay, now let's have a break and let's see it in Unity. Okay, it is already working, but it's not what I wanted to show you here. What I want you to understand is that here we use something like depth first search. I'm not good at it, but if you've never done something similar, it will be very hard to understand. So first I want to show you how does it work based on this example. So we have a list of rooms, right? And every room has a neighbor. Like this room has 2 neighbors, this one has 3 neighbors, and we want to find a room that leads to this generator with a biggest amount of jumps. So we have this room, and this room has a neighbor of our target, so the amount of jumps is 1, Now we have this room. This room needs to jump to this one and to this one. So we have 2 jumps. But how does it work? In our algorithm, we will call a function on this room, check if any of its neighbors is a target, and if not, we want to call this function again on this room and this room because those are our neighbors, and give them this one step. So now we look at this room and we already have one step, one jump, and we can't check this room because it is already checked. So we go to this room, it's not the target, so we call the function again on this room, and then we check this room, and again based on this room, and again on this room, we check if any of its neighbors is the target, and if it is, we return the function to this room, telling that we found the path to the target. Now in this room we return the function to this room, and now we return it to this room, and we have 1, 2, 3, 4 jumps to the target. But as you can see, you can go just like this, 1, 2. And that's true because first from this room we went to this one and we tried to find a path. But it's not over, we've just received one path which is connected to this door. Now we want to check this door. So again, we call a function on this room and we have only one jump stored here. So we start with one jump here and we check if you have a connection to the target. We have, so we have to make one jump. So 1 plus 1 is 2. So we return 2 to this room. Now this path needs 1, 2, 3, 4 jumps, and this path needs 2 jumps. So this one is shorter, and we return to our original call that we need 2 jumps to find this room. And we do the same for every room. So now we start with this room, it has 0 jumps, we can't find the target, we call the function again on this room, now we have 1 jump, and on this room we have 1 jump, they check their neighbors, and so on. And finally, we call it on this room, and it returns that it needs 1, 2, 3, 4, 5, 6, 7, 8 jumps for the shortest path to this generator. I know that it might be complicated, so if you feel like it, go back a little bit and listen to me once again. And now we are going to look at the code and explain it again, but with the code. Okay, now let's go back to this checked rooms list. We use it to skip an iteration of this loop. Let's say we start from this room and it returns this path. So we may be sure that those 2 rooms have a shorter path than this room, so we don't need to check them. That way we save ourselves a little bit of time. So here we check if checked rooms contains a given room, and at the end of this loop we add every room which is a part of a path, which we return here, to a checked rooms list. Alright. Now let's go back here and let's see what do we have. We have a new list of rooms, which is our path, and we simply call a new function on a given room and give generator room as a target of this function. We'll have a look on it soon, but first let's talk about this one, which is the easier function. If the path is null, we get an error and we break it. So something is terribly wrong and we don't need to continue this loop, because something is wrong with our generation. Alright, but if everything is fine, we may save the distance, which is just the amount of rooms in this path. And if this distance is bigger than the biggest distance, it starts with 0, we save the index and save the biggest distance. And that's it. If the index is not -1, so if we have at least one room generated, we are able to return the room, which will be our furthest room. Okay, this looks quite easy to understand, so let's have a look on this scary function. You have getShortedPath2, it returns a list of rooms, and it needs a target, but also will use a list of rooms steps and a list of rooms shortest, which is the shortest path to the target. But it can be null, because first we just need a target. The other two arguments are used here inside of the code, not in the room generator. Here we have a helper function, which just tells us if we can change shortest path. So we get steps, we get shortest path, and we can set a new shortest path if the shortest is null, or if the shortest is longer than steps. Now, if it's the first call of this recursive function, that's important, it is a recursive function, so this one can call itself. Now, if it's the first call of this recursive function, steps is null, so we need to create a new list of rooms and assign it to steps. Now we add a new step to our path. And if shortest path is already set and our steps is longer than shortest path, there is no need to check anything else, because if at this stage our steps is longer, it will be longer than our shortest path anyway. So we can return null. First we need to check if the target is our neighbor. So anywhere we call this function, we check if our neighbor is our target, unless this path is already too long to be useful. But if it's still shorter than the shortest, or the shortest is null, we check if the neighbor is our target. If it is, we set shortest to a new list of steps. I mean to a new list of rooms, which is a copy of our steps. And this is very important, because otherwise, if we just assign steps to shortest, you will have a problem with memory management, but it is a little bit too complicated to explain. We don't want this tutorial to be hours long. If the neighbor isn't our target, we need to tell all of our neighbors to look for the target. So we look at the doors. If we've never visited the room and if the door is active, we grab the room which the door leads to and call the same function as our starting function and send there our target, a copy of our test. It is very important, a copy of our tests, and the shortest. Then if the result is not null, so if we don't fail it at this point, so if our neighbor has really something shorter than our current shortest, we check if we can do that, we replace it, and finally we return our shortest. The whole point of it is that we call this function And while it is running, we may create a chain of those functions. So this one at some point calls this one, so we go back to the top, we check everything here, then we in this loop can call another version of this function and we chain them. So as we return shortest, we go one step back to this function, and this return shortest is our result over here. Now we can check if this isn't null and so on. We loop through it, we return shortest, and we go back one step in this chain, check where we are at the result, we do all of it, and we finally return shortest to our room generator and save it as a path. Now we loop through everything here, and finally we have our index. So it's quite a lot of code, and if you've never seen a recursive function and you still understand what's going on, I'm pretty impressed. Good job. Alright, for now we only have a boss room, which is the furthest room. But if you want to visualize the path to the generator, to the starting point, you may use the path which was used to find the furthest room, and then change every room in this path. Let's do that. In the start function, first let's grab this room. Alright, now we don't need this part. Let's cut it and call it like this. Alright, now we may use a new function, setPathToRoom, and give furthest as an argument. Now we may use setPathToRoom with an argument of furthest. Here we get a room, we grab all of the steps from the shortest path to the generator. If you want to, you may see them in the console with this line. Then we loop through them starting from the second room, because the first one is our boss room. And we mark them as path to boss room. And if we don't have a room, we just log an error. Now let's see at this function. It is in the room class. And here we simply change the color to yellow. In Unity it looks like this. We get our room, which is the boss room, and the path from it to the start point. With all of that, we are ready to write our final test. We need to check if we can visit every room. It's number 5, and same seed dungeons are equal is now number 6, because I think it's better organized this way. Alright, we do the same stuff here, so we find the generator, we wait until the generating process is finished, then we get the list of generated rooms, get generator room, and for every room in this list, we check if there is a path to the generator room. And if there is any room that has no path to the original point, we failed this test. And that's it. Okay, let's quickly run this in Unity. Alright, there's green. Alright, there's green. In the next video we are going to add bigger rooms to our dungeon. See you soon!